Hello and welcome to the new style Edexcel GCSEs. These are the ones that go from grades 9 through to grade 1. This is paper 1MA1/3H. It's the third paper in the higher tier. It is a calculator paper and we're picking up in question 4. In a survey, the outside temperature and the number of units of electricity used for heating were recorded for 10 homes. The scatter diagram shows this information. Okay, Molly says, on average, the number of units of electricity used for heating decreases by 4 units for each degree C increase in outside temperature. Is Molly right? Show how you got your answer. Okay. Well, we can see just by looking at the graph that the gradient is going to be negative, which means that the number of units of electricity does indeed go down for every increase in outside temperature. But to find out by how much, we're going to need a gradient, and we can't just get a gradient with all these x's all over the place, so we're going to need a line of best fit. So we take a straight edge. I like to use a clear see-through ruler so I can actually see the x's that have gone underneath the ruler, so that I can see and judge a line that goes roughly in between the x's, so that you've got almost as many x's one side of the line as you have the other side of the line. So we're looking for a kind of an average gradient of all these x's. So I would think that we'd probably go somewhere around here, and we probably want to have something like this. I think this is about right. We might go a little bit here, maybe. Yeah, I'll have it about here, I think. And I don't want to extend the line too far, because that's going outside of our data, and that involves making assumptions about the data that I'd rather not make. So let's leave it somewhere here. Okay, so I've got what I think, I've committed to what I think is my line of best fit. So now we need to find the gradient of that line. So an easy place to look at here, this is about halfway between 80 and 90. So I'll make this 85, and this is on the 0 line. So one of the coordinates I've got is 0, 85. And now here, if I look up to where the 20 is, on the x-axis at 20 degrees C. Actually, I'm going to go the other way. I'm going to start from the line. And that's not on the 20. So I'm going to bring the line down here. This is a cheat I can do on Microsoft Paint. And then I can just pull it straight up here, the same line. And I can make sure that that's a straight line. And I can read it here. This is 39, I think. Each one of those small squares is 2 units, so I'm going to make that 38. So that's 20, 38, I think. So that's 20, 38. What you would do is you would use your ruler or straight edge, and you would look down there, and then you would just simply draw across and see where it ends, where it intercepts the y-axis. So I'm going to commit to 0, 85 and 20, 38. Your figures might differ a little bit depending on how you eyeballed your line of best fit. So to get the gradient is usually given as y2 minus y1 over x2 minus x1. In other words, it's how far up the y-axis it's gone divided by how far across the x-axis it's gone. So it's just rise over run, up over across. So that's equal to, and that's 38 minus 85 divided by 20 minus 0, which is just 20. So let's pull our calculator up. So that's 38 minus 85. Don't worry that it's negative. It's going to become negative. You can see that the slope is negative. So that's negative 47 divided by 20 is equal to negative 2.35. Again, you'll have something different. So long as it's actually, I'll say that was 2.35, so that should be about 2.4. Okay, so, and that's negative 2.4. So the answer that we're looking for is no. And I'm going to type my answer. On average, the number of units of electricity decreases by 2.4 units for each degree C increase. Okay, so that's part A done. So part B, you should not use a line of best fit to predict the number of units of electricity used for heating when the outside temperature is 30 degrees C. Give one reason why. Well, that's basically because you're extending the line outside of the data. You shouldn't extend the line of best fit outside available data. In this case, the reason being is nobody would be using electricity to heat their house when the outside temperature is uncomfortably hot. If anything, they'll be using more electricity, not less electricity, because they've got fans on and they've got air conditioning units on to try and cool down their house. Who uses electricity to heat? Actually, who heats their house? Who heats their house when the outside temperature is uncomfortably hot? Okay, I hope that was helpful, and I'll see you in another video.